Question 17 of this exercise is kind of an interesting question. We have to find the 20th term from the last term of this AP 3, 8, 13 all the way up to 253. So what this means basically is that if you looked at the AP from the end towards the start, so if you looked at this AP from 253 going up to 3, then what would be the 20th term from this end of the AP? And to help you understand better, let me give you a couple of examples. So for example, the second term from the last term would be the term coming just before 253. The third term from the last term would be the term coming before that, and so on. So we have to find the 20th term from the last term of this AP. Now there are two approaches to solve this problem, and I'm going to show you both approaches. But in either approach, we have to first find the number of terms in the AP. So let's do that first. So we have the first term, A is equal to 3. The common difference D can be found by taking the difference of any pair of consecutive terms. So D is 5, and the last term or the nth term is equal to 253. And what we have to do is we have to basically find n, which will give us the number of terms in the AP. So if we apply the relationship for Tn in terms of A and D, we have Tn is A plus n minus 1 times D. So let's plug in the values. So Tn is 253, the nth term or the last term. A is 3 and D is 5. So 3 plus 5 times n minus 1, and this gives us 5 times n minus 1 is equal to 253 minus 3, that's 250. Now let's divide by 5 on both sides. So n minus 1 is 250 by 5, that's 50, and this means that n is equal to 51. So the term 253 is the 51st term of the AP. In other words, this AP starting from 3 and going up to 253 with a common difference of 5 has 51 terms. Okay, so now that we've calculated this, let's come to the actual question of finding the 20th term from the last term. Okay, in the first approach, we will find the index of the 20th term from the end, and then we will find that term. So basically we know that the term we are trying to find is the 20th term from the end or from the last term. But what is its position or its index in the AP in its original form? So we will find that, and then we will find that term. So this is kind of tricky for some students. So follow me carefully as I explain how to find this index. So I want you to imagine the AP as this series of boxes. So this is the first term, this is the second term, and so on. So each box represents a term of the AP. Now the last box is the nth term of the AP, but this is the first term from the end. The second last box is the n minus 1 term from the beginning, and this is the second term from the end. Then this term, this box here, is the n minus second term from the beginning or the third term from the end, and this box here is the n minus third term from the beginning or the fourth term from the end. So what pattern do you see? So the nth term in the AP is the first term from the end, the n minus first term is the second term from the end, the n minus second term is the third term from the end, and the n minus third term is the fourth term from the end, and so on. So if you see this pattern, you see how this 1 is related with 2, 2 is related with 3, 3 is related with 4, and so on. Yeah. So if we have, so let's say if we talk about the third term from the end, that will be the n minus second term from the beginning. So in general, if we have the kth term from the end, it will be the n minus, what is this? This is, so if this is k, then this is k minus 1. So the kth term from the end will be the n minus k minus 1, this term from the beginning. So for example, the 20th term from the end will be the n minus 19th term from the beginning. So that is the key idea in this first approach. So the index of the 20th term from the end will be n minus 19. And what is n? N is 51. So 51 minus 19 is 32. So the 20th term from the end will be the 32nd term from the beginning. So the position of the term we're trying to find is 32, and now we can easily find the term T32. So T32 will be A plus 31D, and A is 3. So 3 plus 31 into D is 5. So 31 into 5 is 155. 155 plus 3 is 158. So the 20th term from the last term, or the 20th term from the end, is 158. Okay, now let's discuss the second approach. So in the second approach, we will consider the reverse AP, the AP that is the reverse of this original AP, and then we will find the 20th term of that reversed AP. So the original AP is 3, 8, 13 and so on till 253. So the reverse AP is 253, and then the next term will be 248, because the common difference of this reversed AP will be minus 5, because the common difference of the original AP is 5. And this AP will then go all the way up to 13, 8 and end at 3. So in this reverse AP, the first term is 253. The common difference is minus 5. And now all we have to do is we have to find the 20th term of this reverse AP. So T20. So this will be equal to A plus 19D, 20 minus 1. So A plus 19D. So A is 253, and then we have 19 into minus 5. So 19 into minus 5, and then we have 253. 19 into minus 5 is minus 95. So 253 minus 95, and that is equal to 158. So we get the exact same answer as the first approach. And personally, I prefer the second approach because that is quite clean, and there is less chance of making a mistake. In the first approach, I have often seen many students make this mistake of taking the index incorrectly. So instead of taking the index as n minus k minus 1, they take the index as n minus k. So for example, the mistake they will make in this case is the 20th term from the end. They will write it as 51, the number of terms, minus the 20. So this term from the beginning. So that is the 31st term, and not the 32nd term. And we saw that the actual index of the 20th term from the end is 32. It is not 31. So students tend to make a mistake in approach 1, which is why I prefer approach 2. But as I said in the beginning, both approaches are correct. And if we can keep this small idea in mind, that the kth term from the end is n minus k minus 1, this term from the beginning, then you will not face any issues even with using approach 1. To learn more about how QMath can help you crack school and board exams, explore QMath Leap, a live online classroom program run by highly experienced and committed teachers.